Okay, so we're getting ready to do Module 1, Lesson 2, Section 1.8, Introduction to Variables, Algebraic Expressions, and Equations. So for the first part, we're just going to go ahead and fill out the vocabulary you'll see in this section, even though we'll kind of talk through it and about it more as we go through the lesson. So number 1, a letter that represents a number is called a variable. Number 2, a combination of operations on letters, variables, and numbers is an expression. Sorry, it may get ugly. That's expression. Sorry, I ran out of room. Number 3, 3x minus 2y is called an expression. Because you'll notice an expression, it can have numbers, it can have letters, it can have pluses, minuses. You'll notice the thing it doesn't have is the equal sign, and we'll talk about that in number 4. Finishing number 3, and the letters are called variables. So the x's and the y's are just your variables, your letters. Number 4, a statement in the form of an expression equals an expression is called an equation. So as we go through this lesson and continuing on, you'll notice that really the similarities between expressions and equations is they both have numbers, they both have letters, they both can have pluses, minuses, but the difference is equations have equal signs, expressions do not. So objective number 1, evaluate algebraic expressions given replacement values. So the directions, evaluate each expression for. So if you notice, all 4 of these right here are expressions. None of them have equal signs, do they? So we are evaluating expressions, and they're telling us over here what to go replace our letters with. So notice instead of x, I'm replacing it with 12. Notice instead of y, I'm replacing it with 4. And then instead of a z, I'm replacing it with 3. So as we move through number 1, really what I suggest you do, especially as they get more difficult, go through the expression, and every time you come to a letter, I want you to put parentheses. So notice that's all I did. Those are parentheses, even though they're ugly and sloppy. I apologize. And then it's like we're leaving a blank. So now instead of the x, I'm replacing x with 12. That's what my directions tell me to do right here. Instead of y, I'm replacing my y with 4. So I'm putting a 4 here. And then z, instead of z, I'm replacing z with 3. So here in this problem, just because it's more basic, it honestly doesn't matter whether those parentheses are there or not, because notice each number is just inside the parentheses, that's it. So here all we have is addition and subtraction, so just work it left to right. 12 minus 4 is 8. 8 plus 3 is 11. Because once you replace the letters, you then think of your order of operations that we talked about in 1.7, okay? So checking out number 2, we're using the same replacement values. We know x is 12, y is 4, and z is 3. So as we look at this next one, I'm going to go through, and every time I see a letter, put parentheses. So I'm just leaving that blank. So instead of x, I'm plugging in 12. So 12 is going here instead of x. And instead of y, I'm replacing y with 4. So now think order of operations. Well, we take care of parentheses first. Is there anything inside the parentheses? No, they're just numbers. So there's really nothing to go as far as parentheses go. Next is exponents. Do we have exponents? Yes, we do. Right here, 12 squared, 12 times 12 is 144. And if you needed to go to the side and do some arithmetic, that's fine. And then we have multiplication. So go ahead and bring down what we're not using, 144 minus. 4 times 4 is 16. And then finally, 144 minus 16 is going to be 128, I think. 128. If I can subtract right, I hope I can. Check me on that one. Okay, so the next one, example 3, I'm going to go through, and every time I come to a letter, I'm going to put parentheses. And again, instead of y, I'm replacing y with 4. Instead of z, I'm replacing z with 3. And here's a Z also. So next, go through parentheses. Notice within the parentheses there's nothing to simplify. So next step is exponents, no exponents. Next is multiplication division. Notice we have a lot of multiplication going on here, so I'm going to go ahead and just multiply one thing first. 2 times 4 is 8, and I'm going to bring everything down. And then in my next step, I'll go ahead and finish multiplying, because sometimes it's just easier to kind of do one thing at a time until it's not so overwhelming. So here we have multiplication. 8 times 3 is 24. 3 times 3 is 9. Notice I bring down whatever sign I'm working with, and then 24 minus 9, 15. Okay? All right, last one on this page. So here is, oh, sorry, I'm trying to grab my pens. Okay, here is example 4. I'm going to go through and put parentheses every time I come to a letter. Instead of Y, I'm plugging in 4. Instead of Z, I'm plugging in 3. So now when I go to evaluate, think about what order you should do this in. So within the parentheses, there's nothing to simplify. Next is exponents, and I do have some exponents. So bring down 4. The mistake people will make here is they'll try to multiply 4 and 3 together. But remember, order of operations, before you multiply, you've got to take care of exponents. So that's why this is my first step. 3 squared, 3 times 3 is 9. Bring down what I'm not using. Now multiply. 4 times 9 is 36. Bring down what I'm not using. On the last step, 36 minus 10 is 26. Okay? Going on to the next page. We still have one more to go ahead and do, and I don't remember my values. Let me go ahead, and every time I come to a letter, I'm going to put parentheses. And let me go back to the other page. 12, 4, and 3. 12, 4, and 3. I hope I plugged in the right numbers. Flip over to the other page if you need to. Make sure Z is 3 and Y is 4. Good. Okay. So now simplify the top, simplify the bottom. Last thing you'll do is divide. So on top, should I multiply or should I just subtract first? Multiply. So 9, 3 times 3 is 9. That's my first step. Go ahead and rewrite that minus 8. Not ready to use it yet. And notice all I have on top is one number, so just rewrite it. Back on top, I still need to finish simplifying. 9 minus 8 is 1. On bottom, 4. And this is all you can do, 1/4. It's reduced. Leave it as is. Perfect. Okay, objective 2, identify solutions to equations. So they want us to determine whether the given number is a solution to the given equation. So example 6 asks, is 10 a solution of this equation right here? So what we do, and this one's a more basic one, so I know you don't have to, but they will become more difficult, so you'll want to know how to do this. So every time I see a letter, I'm going to put parentheses, and then they're asking if 10 is a solution. So every time I replace our letter with 10, go simplify each side of the equal sign. So over here, I have 10 minus 3, which is 7. Always bring down that equal sign. And the right side of the equal sign is already simplified, so there's nothing to simplify over there. So see if this statement makes sense. Does 7 equal 7? Yeah, it does. So what we have just done is proven that yes, 10 is a solution of that equation. So you would tell me yes. If you look at example 7, they want to know, is 3 a solution of 2n equals 12? So again, I'm going to go through, and every time I come to a letter, put parentheses. Instead of n, I'm plugging in 3, and then simplify each side of the equal sign. 2 times 3 is 6. Always bring down that equal sign. Notice there's nothing to simplify on the right side, so just bring it down. Does this statement make sense? Does 6 equals 12? No, it does not. So you would tell me no, 3 is not a solution of that equation. So just plug it in, see if it makes sense. Okay, objective 3, translate phrases into variable expressions. So you'll see this chart right here, and it's just going to come in handy as you go through your homework and just reminding you what certain words mean. For example, if you look under addition, notice the word sum means to add. So if I say to go find the sum of 3 and 5, I'm just saying go add 3 and 5. If I want you to go find the difference of 5 and 3, that just means subtract 5 minus 3. So you can see just certain words mean certain things. So this page will be very helpful to you as we do this next part. Okay. Directions for example A, write each phrase as a variable expression. So notice they said expression, which means there's not going to be any equal signs here. Okay. It also says use X to represent a number. So that just means anything we don't know what it is, we just call it X because we don't know what else to call it. Okay. So number 8, the sum of a number and 11. So first of all, the word sum is telling us to add. So they want us to go add something I don't know and 11. So that's what it looks like, X plus 11. That's what they're looking for. That is it. I do want to talk something about order of things. So when you add, does order matter? Like if I asked you what is 3 plus 2 and what is 2 plus 3, notice they're still 5, aren't they, regardless which order? So just as a reminder, when we add, order doesn't matter. So if you had told me this, 11 plus X, these are the same thing, so the order doesn't matter. Either one would work just fine. Okay, sometimes order matters. Think about subtraction. Order does matter. So example 9, the difference, which difference means to subtract. So we're getting ready to subtract. What am I subtracting? I'm subtracting a number and 30. So you have to remember order does matter, so there's only one way this one could go. And whenever they word it like this, you just keep it in the same order they have it. So X minus 30 is what we're looking for. Number 10, the product of 16 and a number. So we have to remember product means to multiply. Okay, so we're getting ready to multiply. I'll put a dot for multiplication. What do they want us to multiply? They want us to multiply 16 times something I don't know. And you could write it like that, 16 times X. But remember in algebra, whenever we're multiplying a number and a letter together, we can put them next to each other with the number first. So I'd like you to start getting in the habit of writing it like that, even though they mean the same thing. Okay, 11, quotient. What does quotient mean? Quotient means to divide, right? So we're getting ready to divide on this one. They want me to divide 30 and a number. So if they want me to divide 30 and something I don't know, it could look like that. That is perfectly fine to write it like that. But I want you to get in the habit of writing division with a fraction bar as well. So the quotient of 30 and a number, notice it's written in the same order as it's read. Either way will work, but just get used to seeing it like this. It means the same thing. Okay, example 12, 14 less than a number. So this is a tricky one. Let's just do something else real quick before we do 12. What if I ask you, what is 4 less than 10? 4 less than 10 is this, isn't it? 4 less than 10. Notice I said 4 first, but I wrote it second. That's how it is with less than. You will always write it in the opposite order you read it. So 14 less than a number really means that. 14 less than a number. So just be careful. This is a tricky one. 13, 7 increased by 8 times a number. So here we have 7 increased by, so we know 7, get my pen, 7 increased by means 7 plus 8 times something I don't know. Could I have written it like this? Do these mean the same thing? Yes, they do. Either way is just fine. That is lesson 2, section 1.8.